Hello, this is Paul from First Tech. In this lecture, we go over exponential functions, and the major one is to simplify exponential expression. Okay, this is important because exponential is a very important functions. Okay, and the basic is the exponent rules. We have a lot of rules. Let's go over together. The very basic rule is a raised to 0's power always 1, right? And the raised to the negative power is the reciprocal of this. Okay, so a raised to the x power goes down to the bottom. This we call the negative exponent. Okay, the definition of negative exponent. And another is the product rule. So if exponent times another the product of exponent, and they just add the power exponent together. Of course, we should have the same base. Okay, if the base is the same, the product is just added the power together. And do quotient, we call the quotient rule, and is subtract them together. Okay, do the power, if y is a power, x is another power, we call the power of a power, right? So the power rule is do multiplication. We were not going to prove this, you learned before already. And we have another, x is a power of a product. It's like a distribute x to a, distribute x to b. And the name we call the power of a product is we have a raised to the power, b raised to the power, so they are the product. Okay, and a power of a quotient is they are distributed the power to a, distributed the power to b, which means we get the division of two exponent. Okay, the same power. And it is very basic rules. We have one common mistake. Okay, is here. Let me write for you. Someone easily to mix the power rule and the product rule. So can you see if this is correct? If I write, okay, so let me write here. The product rule. Someone probably say this: a x a y times together equals a x times y. This is wrong, right? So this is a common error. So this is wrong. Should be what? Should be x plus y. Okay. The second, we go to the power rule. Do you think this is correct? See, y is the power of a power. If I wrote a x plus y, is this correct? No, this is wrong. This is wrong. Where is wrong? So here. So the power should be multiplication. Okay, don't switch. I mean the easily switch. Okay, if you switch, you get it wrong, the property. And then, so we're going to do, we're going to use this, okay, to show one example how to use this. And you can look at it a little bit complicated. Of course, it's not very complicated, right? So which rule to use? You should have experience. Okay, so we look at the numerator. The base are the same, xx, right? And then the power are different. Do you remember this word? This is product rule. So we can use the product rule first to simplify the numerator, and divided by the denominator. So they are the same. Base, right? It's a quotient rule at the second time. Let me write down. So what are we going to do? So that one, if I write here is x raised to the 2n. Of course, x raised to 2n power. This is what is a power function. Okay, but whatever you can look at it, this is exponent. The form is still the same, right? Because we do have exponent. And this is the numerator. The denominator is here. See, we said that the first we can simplify what? We can simplify the power, the numerator. How do you simplify? So it goes to dx. This is a exponent times another exponent with the same base is add them together. Add them together is how many? Okay, so if I write here, we should use a product rule, right? product rule. So we need to add the 2n and the 3n, the two power together, we get a 5n. See, the new power is 5n. Okay, is added then together, not the times. And then now we have the quotient rule to use because the bases they are the same, but it is the quotient. So what do we have? We have so they are same x. What is the power? Okay, the power is 4n. Why is it 4n? Because we use the quotient rule. Because we use the quotient rule. The quotient rule tells us is to subtract the n from 5n. So 5n minus n, we get a 4n. Okay, so this is the first example I show you. Another example, okay, look at this. Still very similar. However, we did not see the power. So this is the root, but the root we can change it to exponent power, right? Okay, so all we need to do the first, we just change it to power. So we change it to power. Let me write the original. This is kind of a fraction. This is a, b. This is a cube root. So, and usually we like the power, okay, because we have a lot of exponent rule to use. So we wrote this is a radical. This is radical into power. So what is the power for square root? The power was for square root is 1/2, right? Okay, and the square root is something raised to the power of 1/2, and the cube root is something raised to the power of 1/3, right? Is which one? A raised to the power of 1/3. This is the first. So we say we just change to exponent. Okay, we change it to exponent, and then we can use the rule we learned. What's the rule? So we look at the numerator first. This is a product raised to a power called the power of product, right? We use the power of product. Can we see? And put here is a power of product. We use the power of product. See what we get? We will get this kind of. So the denominator as their copy. The numerator, how to use the power of product. Distribute the power to A, distribute the power to B. So we will get A raised to the 1/2 power times B raised to the 1/2 power. You see, this is the power of product. And then know how to simplify. A and A is what? Quotient, right? If someone like do this, put this together, is what? It's a quotient rule. So now we can use the quotient rule. Okay, to simplify A, because the base A are the same. Quotient rule. We do subtract 1/2, subtract the 1/3 is 1 out of 6, right? Okay, so that's all we need. So we will get the answer. Here should be A raised to the 1/3. No, sorry, 1/6 power. Okay, 6. And here is 1/2, still 1/2. Okay, so this is the answer. And that's all. Thank you.